I will continue to explain the transforming method from the base function to the transformed function gx. Here, you must be careful. The transformed function here, inside the bracket, it is 3x plus 15. You must transform this part, 3x plus 15, to this expression. That is to say, you must isolate 3 from the bracket. Put the 3 outside of the bracket. Inside the bracket, just x plus 5 left. That is to say, 3 must be coefficient of the whole bracket. It should not be the coefficient of x. If you are given 3x plus 15, the first step, you need to transform this expression into this expression. That is to say, here, 3 is k. X is x. Here, minus d. But in our example, plus 5, so d equals -5. Here, -2 is the coefficient of a. That is to say, a should be the coefficient of this whole expression. Here, in our example, -2 is the coefficient of this whole expression. On the basis of this part, plus c, here in our example, it is plus 4. So, in this example, let's summarize. A equals -2, k equals 3, d equals -5, c equals 4. Okay, on the basis of this analysis, we can follow the following method to transform this original function or base function to the final transformed function. First, we can figure out the original function. It should be square root of x. This is the original function or base function. First, we can transform this function to the following function, that is to say, this one. Okay, here we can figure out it is negative square root of x. On the basis of this function, we can transform this function to -2 square root of x. So we can figure out it should be like this. Okay. On the basis of this function, we can transform this function to this function. That is to say, -2, 3x. That is to say, every x should be transformed to x over 3. Now, we can figure out the following graph. It should be like this. -2, 3x under the square root sign. Okay, on the basis of this function, we can figure out the following function, this one. That is to say, we need to move every point on this graph to the left side by 5 units. Okay, then we move this function to the left side. Then we can figure out it should be -2, 3, x plus 5 under the square root sign. Okay, on the basis of this function, if we plus 4. On the basis of this function, we can figure out this function. Okay, so we need to move every point on this graph upwards by 4. So this point should be here, that you say it should be positive 4. Then we move this point to here, this point to here, this point to here. Then we connect them to figure out the transformed function gx, that you say this point, it should be here. Okay, then we connect this 2 points to figure out the final graph of the transformed function. It should be -2, 3, x plus 5 under the square root sign plus 4. Okay, this graph is the final graph of the transformed function. So the order should be like this. First, from the base function to figure out this function. Of course, you can skip this step to figure out this function. -2 square root of x. Then you can transform this function to this function. That you say, you should do the transformation of 3 as the factor. Then you can get this function. On the basis of this function, you need to translate the whole graph to the left side by 5. That will say the absolute value should be 5 units, representing 5 units. Then we come to here. Now we transform this function, that is say translate the whole graph upwards by 4 units. Then we can get this final graph. So let's summarize the order. You need to apply transformations represented by the parameters a and k first. Always say before transformations represented by the parameters of d and c. So here, from this one to this one, that you say, you do the transformations represented by a. Then from this step to this step, you do transformation represented by k. Then you do transformation represented by d, that you say, to the left side. Then you do transformation represented by c, that you say, translate the whole graph upwards by c units. Here, c greater than 0, so plus 4. We say the order matters when we do combinations of transformations of functions. You should not reverse the orders. First, a, k, then do transformations represented by d and c. That's the order. You must follow the order. We say order matters.